music, it's easy to both see and hear the difference in pitches. But what exactly is a pitch? Pitch, as you can see, refers to the highness or lowness of the sound. But to really understand it, we need to look a little bit at the physics that underlie sound in general and music in particular. If you've seen SoundCloud, you've seen an image like this, which is actually a representation of a sound wave. Sound waves are what carry sound from whatever's making the noise to our ears through the air. All sounds are made up of three very specific parameters. The first one is duration, how long the sound lasts. The second one is volume, how loud or how soft it is. The third is how high or how low it is, or what pitch it's at. Sound that contains multiple pitches, or worse yet, all pitches, is simply just plain noise. In order to be a musical sound, the sound has to be cohesive. That is to say that it's vibrating in a very specific frequency, making a very specific pitch. The most cohesive form of sound is a sine wave. A sine wave looks like this and sounds like this. The frequency of the sound wave is the function of the distance between the wave crests, as you can see in this image, where that distance is marked as the period. In the case of the particular sound you just heard, that frequency is 440 times a second, which is the pitch that is the standard tuning pitch for most of the world these days. The A above middle C, we know it in scientific notation as A4, is pitched at 440 cycles per second, or 440 hertz. In the case of this graphic, you can see that the two different waves, the periods, are different lengths. In the upper wave, the shorter period would yield a higher pitch, whereas the lower wave would be a lower pitch because the wave crests are further apart. Additionally, off on the left, you can see where it says pressure. The pressure is the up and down measure. That is amplitude of the waves. The higher the amplitude, the louder the sound. As you can see from this graphic, where we have the louder sound on the left and the softer sound on the right. It's also easy to see the closer together wave crests of the higher pitched notes versus the further spread out crests of the lower pitches. So what does all of this have to do with pitch and the relationship between pitches, otherwise known as intervals? An octave is the relationship of two notes that have the same letter name but different octave numbers in the scientific notation standard. In this case, we have A3, which is the top line in the bass clef, and A4, which is the second space on the treble clef, which are one octave apart. As you can see from the numbers of the hertz, or the cycles per second, A4 is vibrating twice as fast as A3. Knowing this, it's pretty easy to see that the tuba and bass guitar are different than the piccolo, at least as far as pitch is concerned. But don't panic. Although it seems like a whole lot to remember, the only important things to remember is, first of all, that there are octaves in music, and that the octave relationship is twice the frequency for a higher octave than the next lower octave. The only other important thing to take away from this discussion is that A440, 440 cycles per second, is the generally accepted tuning standard worldwide. We'll definitely spend more time in class talking about pitch and frequency, but for now, that's it. We'll see you real soon.